So, we're going to look at the binomial model. The binomial model is a way of calculating probabilities for a specific type of scenario. These scenarios are going to be these Bernoulli trials, and they're going to have some properties. So let's talk about these properties and how they work together with this scenario that we're going to look at here. So we have a basketball player, and we're going to assume the shots are independent. We'll talk about what that means, and we want to find the probability that in tonight's game that she makes the first free throw on the fourth attempt. So some pieces that are coming through here. They give us this 82%, which is her probability of making the free throw. Something that happens here is that there's only two possible outcomes. She either makes the free throw or she doesn't make the free throw. And that's this first scenario here. When we have Bernoulli trials, it's going to be that there's only two possible outcomes, and we usually call them success versus failure. So the idea is we have this probability of success here, which for a binomial model, probability of success, we use the letter little p, is the probability of success. And then we use lowercase q to represent the probability of failure. And if these are the only two scenarios out there, then these should always add up to 1. Meaning, if we know our probability of success, like in this case that there's an 82% chance of making it in, if we wanted to find the probability of failure, you just take 1 minus that probability of success. So here we have this probability of success of 82%, and probability here, if we take 1 minus that 0.82, we'll see this 18% chance of failure. So this is getting at binomial because there's only two possible outcomes. She makes it or she doesn't make it. The probability of success, our value for p, remains the same for each trial. So her probability of success is 82%, and it doesn't change after each free throw she makes. That's just staying her probability of making it in. So that makes it a Bernoulli trial. Another thing that comes through is that the trials are independent, which is given to us right here. But often we might have to find that for ourselves. And this kind of links that the probability isn't changing. Like for this scenario, what we're assuming is that her probability of success stays the same. Her skill isn't increasing or decreasing. We're just saying every single time there's this 82% chance. Something else is going to come through that makes it a binomial model that isn't happening in this scenario here, but that we're going to talk about down in our next example. So this first example here actually throws back to probability methods we already talked about. So we have these independent events, and this example here, we're trying to find the probability that she makes her first free throw on the fourth attempt. So what that would mean is we're looking for this probability of that she misses it, and then misses it again, misses it a third time, but then on the fourth time she's gonna make it. So we get this sequence of events going through, and linking back to our probability rules, this brings through and. It's like the probability of, and I'll use Q for fail, and then fails again, and then fails again, and then on the fourth attempt makes it. And we can just use our multiplication rule since we have independence. You take the playing type times the probability of failing, times the probability of failing, times probability of success. So we're going to have this 0.18 multiplying with itself 3 times. I'm just going to use an exponent. And then you finally multiply it by the probability of success. And this would give us a 0.0048, which means there is a 0.48% chance she makes the first free throw on the fourth attempt. So, with this we didn't need the binomial model, and it's because of these pieces where we have independence, which we'll also have with the binomial model, But when they describe what we're finding the probability for, they describe a specific sequence of events. To fulfill this making the first free throw on the 4th attempt, there's only one way that can occur. She has to miss it 3 times in a row and then make it on the 4th attempt. What we end up doing in the binomial model is we're going to look at this scenario, but we're not going to be as specific for the sequence of events. We're going to just say, like, what happens here, she makes 1 out of 4 free throws, and that's what we want to find the probability using the binomial. So down here, and in our example, we looked at the probability that she makes it on the 4th try. What if we wanted to know the probability that she made exactly 1 basket in the first 4 attempts? So note that the order doesn't matter here. It's just she shoots the ball 4 times and we want to know the probability that she makes 1 of them in. So the difference being with this one, it had to happen on the 4th attempt. So now we don't care when it happens, just as long as she makes 1 out of 4. So with this, we start getting more scenarios possible. And that doesn't have to be on the 4th attempt. We could make the first free throw on the 1st attempt, or the 2nd, or the 3rd, 4th. The idea is that we're looking for this probability of 1 success out of 4 trials. And with that, we're going to end up with this kind of OR scenario. The idea being that if she throws the ball 4 times, let's look at the scenario where she makes it on the first shot. Meaning, we have our success, so that 82%, and then she would miss again, then miss on the 4th try. The idea is that she shot the ball 4 times, made it on the first attempt, then missed, then missed, then missed. Then what we have is, or she could make it on the 2nd shot. And remember, when we have or, that brings through addition. And what this will look like is she misses the first shot, makes it on the 2nd, or she can make it on the 3rd shot, which would mean we add on that she misses again, then makes it, then misses. And then our only other scenario is if she made it on the 4th shot, which would look like up above, where she misses 3 times and makes it on the 4th attempt. So with this, we cover all of the scenarios of her throwing 4 free throws, and she makes it 1 time out of the 4 times. We can see in here is, for each of these, the calculation ends up being the same. And that for each of them, like with this one, if we simplified it, we have that 1 success multiplying with our probability of failure 3 times. And the same things right here. We have our 1 success and 3 failures. And our 1 success and our 3 failures. And then for our last one, same thing. So in terms of how the probabilities work together, the same scenario is coming through. It's just that there were 4 different ways that this could occur for this scenario. So it's like we have 4 times, and then we have our 0.82 times our 0.18 being cubed. And this is getting at the formula for the binomial model. And I think of this in terms of 2 pieces. This piece over here, this is getting at the idea of 1 success and 3 failures. So based on the wording of the problem, if we know our probability of success and probability of failure, with them saying that we want her to make 1 basket out of 4 tries, that means she makes 1. And that kind of brings through this exponent of 1 right here. So 1 success, so there's a total of 4 trials here, and this is how the successes and the failures have to distribute. Then our other piece is this 4 coming through right here. So this 4 comes through when order doesn't matter. So we have this set up pretty much in this first example, was that because there was a specific order, there was only one way for this to occur. But as soon as we made the order vague and saying we don't care what the order is, then we need to think about how many ways can this occur. So this 4 is calculated from the number of different ways to have 1 success out of 4 trials. And it just happens to be in this scenario that it ends up being 4 different ways. But if you can imagine, say she was going to shoot the ball 10 times and I want to see the probability that she makes 2 of those 10, if I think about all of those different scenarios, we'd end up with a very long list. So this number right here is calculated from something called a combination. Combinations are calculated for this: how many ways can we have a certain number of successes out of some number of trials. And what we're going to do is see how it's calculated by hand, but then I'm going to show how to use Excel's kind of the easiest one for this. There's also a way to do it with the calculator where it'll just give the number for you.